Again, and welcome back to another video on grade 9 science, current electricity. Today we're going to be looking at resistance. So if we take a look at electrical resistance, in general, you can think of it as the ability of a substance to slow down electrons or oppose the flow of electrical current. Okay, so when you think about it, it's really quite an easy concept, and you know this. You know conductors from our study of chemistry, and you know that metals are good conductors, and so they have a very low resistance. And you also know that insulators, such as some nonmetals, remember testing sulfur, have very high resistance, and rubber has very high resistance, glass, wood, all of these have very high resistance, and you can see that glass and ceramics are used to insulate high voltage power lines so that you don't get electrocuted when you walk past them. Electrical resistance is measured in ohms, OHMS, and the symbol for it is omega. This will become more important later. I talk about this in a short time, but a resistor in a circuit has a symbol that actually looks like a wiggly line. And it looks like that. And so you could put how many ohms a resistor offers by writing 10 ohms over top of the resistor. Okay, let's think about electricity again in terms of bees. We've talked about an analogy with bees. We've talked about an analogy with water. Remember when we talked about current with bees? Current was the number of bees. And we compared voltage to how angry the bees were. Well, what we want to look at is how do we compare something's resistance to something appropriate with bees? Well, we could think about how easily can bees fly through an area. And so low resistance would be an area such as a meadow, a grassy field where they can fly along and not be impeded by anything they come across. A substance of high resistance, with our analogy with bees, would be a dense forest where they're always trying to dodge and weave between trees and leaves. So you can kind of maybe understand resistance a little bit better that way. Okay. There's a bunch of factors that influence resistance. So we've already talked about these. So if you have a conductor, as you know, they have very low resistance. Well, if you have an insulator, they have very high resistance. And there can be some things in between. Remember we talked about some metalloids, which are called semiconductors, and they sometimes have very high resistance. They sometimes have very low resistance. So that was type of material. The second type of material that we look at, or the second factor influencing resistance is cross-sectional area of the conductor. And this just means how big around is the cable. And you can see here, we have a very, very thick red cable right there, carrying a lot of current. And so it has low resistance. We want it to have low resistance so it doesn't overheat. If you go to your toaster and you peer inside your toaster, you see that there's some very, very, very thin wires. Those very thin wires slow electricity down a great deal, and they actually turn electrical energy into heat energy. And that's how your toast gets toasted, and that's why they glow bright red and hot. Okay, so factors influencing resistance, type of material, cross-sectional area. Let's look at some more. Length of the cord. If you want to get as much electricity to an appliance as possible, you should use the shortest cord. So the length of a conductor is a big deal. If you have a short cord, you're going to have low resistance. If you have a very, very, very long extension cord, you're going to have a lot of resistance. And so you can lose a lot of energy and power by using too long an extension cord if you don't need one. Temperature is also a very interesting factor that influences resistance. So the higher the temperature of a substance, the more resistant it is. And some of you have seen pictures like this before. This is a picture of a superconductor. The colder some substances get, the less resistance they offer. And in fact, some substances have no resistance, absolutely zero resistance at low temperatures. So electrons will just keep running through them forever. And these are actually called superconductors. Okay, they're extremely interesting, and it's hoped that we can someday have superconductors at room temperature. Let's talk about resistors in a circuit. As I mentioned before, here's a symbol for a resistor. And resistors are simply used to slow down or oppose the flow of electricity, and that's done to protect components of a circuit, maybe the screen of your cell phone, from getting too much power and burning out or shorting. You can tell how many ohms are in one of these resistors by the number of colors, or the different colors that the code is showing you on the side of a resistor. We're not going to get into how to read resistors in this class, but it certainly is an interesting concept that when you look at a resistor, you can tell exactly how many ohms are in that resistor based on its color. So here's your homework. I would like you to read over pages 564 to 566 and answer questions 1 to 7 on page 566.